Welcome to this presentation where we are going to do some sort of representation on airport gate scheduling using a grid heuristic, and this presentation is presented to you by myself, Salam Al-Shidi. So welcome to this presentation. So we'll start direct tips of this heuristic algorithm. So as in each airport gate assignment problems, we have a set of flights and a set of gates. So first we are going to create two sets of flight. One of these sets are unscheduled flights and the other one is scheduled flight. So at the beginning, initially, we'll put unscheduled flight equal to 108, which is the size of the set unscheduled flight, and the size of scheduled flight will be 0 initially. Second step, we are going to sort those flights according to the arrival time, of course with considering the size of the flights, because as we know that the objective of this algorithm is to maximize the assignment of large flights on the gates. So we are going to consider the large gate first. We are going to sort them according to their arrival time. Then we will move to the medium flight size. We will sort them again to the arrival time, and at the end we will sort the small size flights. Step 3, we will let uj equal to where j is the number of the gates, and uj is the utilized time windows on a gate, where ai is the arrival time and di is the departure time. And note that uj can contain multi-time windows, as gate can occupy more than one flight, but of course those flights should not overlap, and they should also fulfill the conditions which we are going to explain. So this is step 4. In step 4 we are going to do the following for each flight, starting from large size flights. So we are going to choose first the gate with minimum distance, which is close to 0, and we are going to check that if the arrival time and departure time is not overlap with the set uj, which is the utilized time windows of the gates. Then we are going to check the type of the flight to the type of the gates, if they are international or they are domestic. So if they are going to if the each flight means international flight should be assigned to international gate, and also domestic gate flight should be assigned to a domestic gates. The fourth condition is the size. So the size of the flight should be less than or equal to the size of the gate. So the gate cannot the gate can occupy a flight either from the same size or lower, not greater than its size. Now again we will check if the gate have scheduled maintenance, and we will make sure that those scheduled maintenance is not overlapping with the arrival and departure time of the flight. If this gate exists, we are going to assign a flight I to this gate, and we are going to update uj, where we are going to add 15 minutes, which is the changeover time of the gate, which used for cleaning and preparing the gate for the next flight. And this 15 minutes should be added once only to the departure time. So we don't have to add this changeover time every time we update the set. It's only when we update the set for example, first window utilized, we'll add this 15 minutes, and we'll not add it when we add another time window. Yeah. And at the end we are going to update the size of sets scheduled flight and unscheduled flights, and will obtain the walking distance, which will contain all flights assigned in the set. And now we'll have a look at the pseudocode of this greedy algorithm. So as we see, it's explained here. Set, we will have input set of unscheduled flights and set of scheduled flights, and we will let uj equal to the time window utilized from the gates, where I is 1 from 1 to n and g is 1 to n. And initially we will let unscheduled flight equal to 1 to n, which is the number or the set of the unscheduled flight, and the scheduled flight will be equal to 0 initially, of course. And then we will go for each flight I in 1 to n. We will do the following: we will check the conditions. If while gate J is in maintenance, we are going to check again if the time is overlapped with the arrival and departure time of the flights. And if this gate is if the assignment of flight I to gate J successful, then we'll assign this flight to gate A, and we'll update all the sets which we discussed about before. And here we did some trials on this heuristic. So at the beginning we said that unscheduled flight is 108, which is the sets of the size of the sets is 108, and the size of scheduled flight is 0 initially. Uj is equal to 0. So first we said that we have to sort the flight according to the arrival time, considering the large size. So first large size is flight 1. We record its arrival and departure time, which means the occupation window or the duration of the occupation, and its type international. Its size is large. Size of flight 1 is large. So gate and maintenance, we mentioned the gate and maintenance. What are the gate and maintenance? To check either this maintenance time is overlapping with the flight with the first flight we choose. So based on smallest distance, we check first gate will meet flight 1 condition is gate 16. So we'll assign flight 1 to gate 16, and we'll update our size of sets. And we'll keep doing the same with the next large flight is flight 4, and we'll record the time now of the arrival and departure time of this flight, and we will go with these trials one by one. And this is another 3 trials of this presentation of this heuristic. And we come up here now. We complete the heuristic by using Gantt chart on Excel. And this is a Gantt chart of the assignment, and we can see the green color is the large flights assigned to the gates. So on the y-axis we have the gates, and on x-axis we have the time in minutes. And in green color we'll have the large flight, blue color we have the medium flight, and orange color we'll have the small flights. And here is a small comparison about what we got in simplex and what we got in the greedy heuristic. We found that out of 108 flights in simplex, we got 60 flights assigned on bridge gate with maximum walking distance of 3864, while on greedy heuristic we found that 69 flights assigned. But here the bridge, the walking distance with greedy heuristic is more, because in greedy heuristic we put more weight on assigning more number of flights on the gate, while in simplex the weight was giving more to minimize the distance of the flight. And out of 60 flights assigned to gates in simplex, Out of 60 flights, 56.6% of those flights are large in size, and 41% is medium in size, and 1% is a small size, while 8% of large flight and 37.5% of medium flight assigned to open parking lot. While in Greedy Heuristic we got 33 flights, which is 47.8 flights assigned to bridge gate, which is not much difference from the Cplex, and we found that 50% of the medium size flight assigned to a bridge gate, and here is where we made the difference between the walking distance in Greedy Heuristic, because we assign more medium size flights to the to the bridge gate. That's why we got more distance. While if we compare the large flight, the difference is only 1 between both Cplex and Greedy Heuristic. This is all about this algorithm, and thank you for listening.